All right, we're going to finish up our properties of logarithms today. The last thing we need to look at is using that change of base algorithm from yesterday and use it to approximate um, the value of a log in some base that we can't normally calculate. The nice thing is, I know like with my cell phone, the calculator, I guess it doesn't matter which way I hold it, it does have logarithms and natural logarithms, logarithms and LNs, which is kind of nice. So these can be done with just about any calculator, as long as it has that ability to do logarithms. And I'll show you, it doesn't matter which one you use. If you use ln, that's fine. If you use log, that's fine. So what we're going to do is use our change of base. So log base 7 of 10 is going to be the same as log of 10 divided by log of 7. And in your textbook, they're going to ask you to round these. I should have put it in the directions here. To 6 significant digits. So if I go to my calculator, I want to do log of 10 divided by log of 7. And I would expect to get an answer larger than 1, because I know to get 7 to some power to equal 10, that power has to be bigger than 1. So if I hit enter, and 6 significant digits, so that's going to be 5 digits after the decimal, 1.18329. So I'm going to change this. And then just to show it doesn't matter, you could use the ln as well. ln 10, make sure you close parentheses if your calculator puts them in. You get the same approximated answer. The thing you can't do is do log for the numerator and ln for the denominator. So you just have to be consistent with whichever function you're going to use. So I'll do this one using natural log. So it's always going to be the log or the ln of the thing we're finding the original question for, and then the log or ln of the base. So ln of 6 divided by ln of 4. 1.29248. And so the process is going to be the same for each of these. Log 1/4 of 15. Log of 15. Log of 1/4. Of 15 divided by log of 1/4. And again, you can use division. You could convert it to a decimal. 0.25 would be fine. We get negative 1.95345 if I round it. Again, just showing that this does work with the ln function as well. As long as you do both with log or both with ln, you're okay. And the last one. Log base 12 of 6. And then just a couple of things I want to mention about the third example we did. But let me get this last one done. Here we're trying to get a value less than 12, less than our base. And you'll see what happens when that situation arises. There we go. So we get a value less than 1. So 0.721057. And so a couple of things to point out. First of all, Mr. Gingrich's writing is pretty sloppy. All right, there we go. If you have a fraction base and a whole number value, or it could be the other way around. It could be a whole number base and a fraction you're taking the log of. You're going to get a negative value. If the thing you're taking the log of is smaller than your base, but they're both whole numbers, you're going to get a value between 0 and 1. Every other case, you will get a positive answer for your logarithm. All right, and there's your assignment. 8 problems, just converting or getting an approximate value, 6 significant digits, and I think that's pretty much it.
Okay, when's like the final day for me to make sure I have everything?